No, but we'll take today's lesson tomorrow. Tomorrow we have three.
Who said they didn't send the email? They sent? No, they didn't.
Wait, hang on. Tomorrow we have 3 hours of physics?
Yeah.
Back, including the lab. Back to back or
Separate.
1 plus 2? Yeah. So we'll do the lab in the 2 and we'll continue the materials in the 1. That's fine. And do we have maths tomorrow? No. Coffees. Muffins. Huh?
No, it's missing I.
I?
It's missing I.
What do you mean?
How can you write the M?
Like this. Do this.
But it's different than normal.
No, look at the keyboard.
It's different.
No, it's the same as that.
It's like a little bit like it.
A little bit like 8. And
It's not like that. It has to be like circle.
OMG.
Yeah.
Continuing from this nonsense. Right. Got that? Yes? So, last time we were talking about domain and range. And we have this nice diagram for representing domain functions and mappings when we just have single values. Like for example, let's say I have a function, a mapping f, and f takes something from this set, let's say ABC, and then gives you something from this set, XYZ. So this is called a mapping. This set is called the domain, and this set is called the codomain. And you can represent it on a diagram. This is ABC, this is XYZ, and for example, maybe my F takes A and gives me Y, it takes C and gives me X, and it takes B and it gives me X as well, for example. This is called the domain, this is called the codomain, and this part here is called the range. Now, you can see there's a bit of a difference here between range and codomain. What exactly, from the diagram, is the difference between range and codomain?
Range is about 2 functions, and domain is all of them.
No, you're making it more complicated. Make it simpler.
The codomain are all the possibilities,
Yeah.
but range are the exact ones.
Give me a different word than exact.
Is the range from X to Y?
What?
Is the range?
Yeah. Yeah.
The corresponding values of the domains.
The range
Good.
is the range.
Hey, you're right. So the codomain is everything in the what we call the target space, the end of the mapping. But the range are only the values that the mapping achieves, that reaches. As you said, they're the values in the space that correspond to something that came from the domain. In other words, the range are only the values you get returned to you. This Z, what value in the domain gives me Z?
We don't know.
Nothing actually. So Z is, although Z is in the codomain, it's not in the range because you can't land on a Z from the domain. So this means there's more terms and definitions we can have for our functions. Let's have a look at the definitions. But just before going on to the different types, we'll just define exactly what range is. So definition. The range of a mapping F is f of x where x is in the domain. So simply put, the range is all the values of f of x. Example, what's the range of f of x is x squared? What's the range of x squared?
Y.
No.
The range of x.
Y squared. Or
No. Think about what are the values of f of x. If f of x equals x squared, what is the range?
All values of y.
All the square number.
No! Stop being stupid. Think.
the square root.
Oh, no.
Repeat the question.
If f of x equals x squared,
Yes.
what is the range?
Fx.
X squared.
Ah.
Now that's wrong, but that's actually been the closest answer so far. But that's still wrong. It's not or. It's definitely not or. It's all the positive numbers.
Infinity?
Yeah, because it doesn't fall. Oh my god.
Yeah, and now you're realizing, oh, I must have seemed stupid in front of Stephen just a minute ago. Yes. Now let's try this again. Let's say we have a function like sine x. What's the range of sine x?
0, 1 to 1. Y equals negative 1 to 1.
Thank you. Minus 1 to 1 is the range of sine x. What is the range of ex? What values can you get for ex?
Ex.
Say Lee?
Bigger than.
Lee's given an answer now. Let him give an answer. Go ahead. Bigger than? I can't hear you. Speak up.
Bigger than 0.
Bigger than 0, correct. The range is everything bigger than 0. Including 0? No. So the range is all the values of f of x. Yeah. What is, finally one more, what's the range of 1 over x?
Except 0.
Except 0. Ah. Oh, you're so tricky, Stephen. So tricky. You got that? 1 over x is everything except 0. Because you can't have 1 over x equal to 0. Never happens. So now let's look at the different types of functions. So the different types of mappings. So the nicest mapping we can have is what's called a 1 to 1 mapping. And this mapping,
Linear.
stop,
Okay.
takes one value in the domain and gives you only one value in the codomain. So in other words, nobody shares a value. Everyone gets their own value. So the definition of 1 to 1 is that if x1 does not equal x2, and these are both in the domain, then f of x1 should also not equal f of x2. In other words, different x's make different f of x's. Example, ex. If I pick a different x, do I get a different answer? Yes, I do.
Miss different answer.
Yeah. But x squared is not 1 to 1 because I can pick two numbers which are different but get the same answer. Like what?
2 and minus
2 and minus 2. 2 squared? 4. Minus 2 squared? 4. So x squared is not 1 to 1. For example. What about x cubed?
1 to many. Or many to 1. No, wait.
Now you say,
One-
hey, you
one to
all
one,
want
one
to
to
break it
one.
up.
1 to 1.
It's too late.
No.
That answer is not accepted. And the correct answer is 1 to 1.
Yes.
Because when you cube a number, you always get a different result.
Yeah. Doesn't matter.
What about square root? 1 to 1 or not?
No.
It is 1 to 1 because when you square root, you always get a different number. If you're telling me it's not 1 to 1, then you need to give me two different numbers that have the same answer. Square root of 2 and
-2.
you can't have square root
Yeah.
minus 2. Yeah. Yes, indeed. Okay. This is one
About 3 cubed.
x cubed. But 3 squared and 9 is the same number. You need to give me different numbers. Alright. So the opposite of 1 to 1 is many to 1. So the definition here is if x1 does not, oh well, no, let me not put it a different way.
We did 1 to 1 and 1 to 2, and then 1 to 2, and then the opposite.
What are you telling me?
I don't know.
Please, I'm so hungry. I had so little for breakfast. I'm just running off of coffee right now, and I don't even have much left. Alright, many to 1. So, many to 1 means there exists an x1 not equal to x2 in the domain such that they are equal. So it's the opposite. That you can have two x's which are different, but you actually get the same answer. Examples: x squared. You could have 2 and minus 2. Same result. What about something else now? What about sine x? For example, sine of 0 is 0. Sine of pi is also 0. So sine is many to 1. Can you think of another function that's many to 1?
Cosine.
Cosine. Anything else? Tangent, yes. X power 4. Yes.
Power 6.
Power 6. Maybe even power 10. Ooh, possibly. So many to 1, the graph would look like this. That you have possibly two different values, but they get mapped to the same value. As an example. Okay, so write this definition down, and then we have, you can probably guess now, 1 to many, and then many to many. Can I scroll down actually? Yeah, okay, so the previous mappings are called functions. Because they take an x and they give you a y. The next two aren't really functions, they're what you might call ill-defined or badly defined, and you'll see why in a minute. So we have, what do they say, 1 to many, like this. So the definition is, we could have there
Equal x's.
exists a y1 not equal to y2 in the range such that f of x equals y1 and f of x equals y2. In other words, you can have one value of x that goes to two different values in the range. Now this is actually really bad. This isn't a function, because in maths, when we've been doing functions so far, we don't like situations where we have two different answers from the function. We always want one answer from one function. So an example would be in maths when we have square root of 9. Sometimes students make the mistake to think that the answer is plus or minus 3. This is technically wrong. The square root of 9 is only 3, not minus 3. This is a very, very common mistake students make. They think that square root means plus or minus. No.
That's what we were taught.
But then you were lied to. You were lied to.
Why were we taught lies then?
I don't know. Now, it's possible that you weren't told this, but you were told something similar to this and you're mistakenly remembering it. So, for example, if I have x squared equals 9, then it is true to say x equals plus or minus 3. That is true. If I say x is equal to square root of 9, it is only true to say x equals 3.
That makes sense. Is that because there's no sign beside the square root?
Yeah, because technically square root is defined to have only one answer, so that it's a function. Because we don't like functions that have many answers, because then that is not well defined, ill defined. So this is what do I call this one? This is one to many.
Okay, but you said the first one is wrong, so it's not an example of one to many.
But there's no function here. You see, this is the key difference. Here you're solving an equation, and when solving an equation, you love having multiple answers. Here you are evaluating a function, so you do not like to have multiple answers. So the difference is between the verb solving and the verb evaluating. What?
It's not nice.
No, it's beautifully nice.
No, it's ugly.
No. Here, what are you doing? You're solving for x, correct? So you like multiple answers.
Yeah, but we're calling a verb.
And here you are computing the value of the square root of 9. So you like to have only one answer. It's like, for example, the difference is if I said, for what ages can you go to the cinema to see Terminator 1 or something? So you can say people who are age 18, 19, 20, 21, 22, etc. They can go to the movie. We have multiple answers because we're solving. But if I said to you, what is your age? You would be very unhappy if I said, I am 18 and 19. You wouldn't like this. Right? So this is the difference here. I'm sorry if you were lied to in the past, but you need to accept this now. This is the reality. I can see in your face you're not accepting it. You're thinking, Stephen's wrong, and I'm going to go home and prove that he's wrong. But then you'll go home and forget about it, and, I don't know, get takeout or something. Right. Continue. Are you happy-ish with this?
No, but it's...
You're not happy with this. The same problem he has? Okay. You can trust me on it, though? No comment. Alright. The last one of the four... Yeah, I know. Definition is many to many. So this is the worst one. The worst one. So this is y1 does not equal y2, and these are in the range. And then x1 does not equal x2, and these are in the domain. And you have a situation where fx1 equals y1, fx2 also equals y1. So this makes it the one to many. But then you also have fx2. Actually, do I need a second y1? fx2
equals
y2.
And fx1 equals y2.
Yeah. fx.
1.
I'm getting a bit confused. You know what, before I write it down, let me just draw it, what it needs to look like. This will help me. So many to many means you could have one here that goes to two values. Two values. And then you have another one here that goes to some, same one. Well, I suppose it doesn't have to be these two. So I'll make the definition a little bit neater then. So you could have two values, one value that goes to 2, and then this other value here just needs to go to one of the values you already used. So like it could even just go to, say, this one here. So many to many is a mapping that is both one to many and many to one. Like we'll see in a moment. So, do you remember the definition of unto?
Yes, all real numbers.
Yeah. So in general, the technical definition is unto means that the range. Yeah, but if we're not necessarily dealing with real numbers like here, then we say the range is equal to the codomain. That, in other words, nothing is left missing in the codomain. So this one, although it's many to many, it's unto, because there's no element here that does not, that is not mapped from a domain value. So that's unto. So we have so far 6 definitions. We have the definition of range, one-to-one, many-to-one, one-to-many, many-to-many, and unto. I don't know if there's more definitions in this lesson. Let me just check. So in question 1 we have to say what type it is, and question 2 we have to say if it's one-to-one or many-to-one. Right. Okay, can I continue? Continue? Yeah. So, how do the graphs, or how are the graphs affected if it's a different type of mapping? So what I'll do is I'll draw the 4 possibilities to demonstrate the 4 different graphs. So the nicest one we love to have is one-to-one. Then the second one, which isn't so bad, is many-to-one. And then the next one is one-to-many. And then finally, many-to-many. So we have x, y. I'll draw something like this. Yeah. Right, so how can we tell what each function is? So a function that is one-to-one, the way you can tell it's one-to-one is that if you draw a horizontal line anywhere and a vertical line anywhere, it should only meet once and once. If it's many-to-one, when you draw a horizontal line, it should meet many times, and when you draw a vertical line, it should meet only once. If it's one-to-many, when you draw a horizontal line on the graph, it should meet once, and when you draw a vertical line, it should meet many times. And many-to-many is when you draw a horizontal, you get many values, and a vertical, you get many values. This was a question I've seen in the exam twice now, where they give you 4 graphs and they ask you to match it to its type. And you can see, if you remember this, you can match it pretty quickly. Please draw this in your notebook.
They show you the graphs.
Yeah. Continue. Continue. Yeah. Okay, so the next thing now is how can we check if a function is one-to-one or one-to-many? So for example, let's say we have a function like 2x plus 3, and I want to know, is it 1-to-1 or if it's many to 1? Well, this one's clearly 1-to-1, but how can we check? So I'll take a simple example to demonstrate the method. Okay, what you do is, step 1, you say let x1 not equal x2, and these are in the domain. So what's the domain for this function? All real numbers, so all real numbers. And then step 2 is you try to solve fx1 equals fx2. And if this is solvable or not will tell us what we need to know. So here, we want to try and solve 2x1 plus 3. This will equal 2x2 plus 3. I can cancel the 3's, yes? And then what can I cancel here? Yeah. Can we solve this? Can we find a value of x that's equal to x? No. No, because you might say, well, this is obvious, because we just say x1 equals 1 and x2 equals 1. That's a solution. But no, we're forbidden from doing that because at the very beginning we said x1 does not equal x2. So this is not solvable. And that implies it is 1-to-1. If this was solvable, then that would make it the many-to-1.
Do we have to write one down? Like, can't we just choose two numbers, put them in, and see what results we get? If they are the same result,
No. It's actually, for proving it's 1-to-1, we'd have to do this. But for proving it's many-to-1, we could simply find two numbers which are different that give us the same value, but that's not as easy as it sounds sometimes, which is what I'm going to do next. Can I continue? Yes? No. Continue? Continuing. So let's take this function. X squared plus 2x plus 2. 1 to 1 or many to 1? Okay, you just give me two values that are different but have the same f of x. Yeah, now I get what Stephen was saying. It is 1 to... No, it is many to 1, yes. Because if you draw the graph, you have many to 1.
Yeah.
So just give me two different x's that make this the same. Now you're going to start trying different values of x, aren't you?
Any two values of x will give you the same value of y.
Does x equal 1 and x equal 2 give you the same value of y?
No, it doesn't.
So it's not any two values of x. So give me a pair of x's that make the same y.
You need to solve it.
This doesn't have any roots.
Quadratic formula.
Doesn't have any roots. Well, let's make sure it doesn't have any roots.
It doesn't.
Complete the square.
No, it definitely doesn't. No.
No, it doesn't.
8 plus 2 it doesn't.
Yeah.
4 minus 8. Oh yeah, no, it definitely doesn't. Right, so let's use the method I showed you a moment ago. So step 1, we say x1 does not equal x2. And step 2, we try to solve fx1 equals fx2. If this is solvable...
But we said many to 1, so...
Yeah, but this is what I'm trying to prove. I know what the answer is, but let's pretend we don't and we're checking it. So, if this is solvable, it's many to 1. And if it's not solvable, it's 1 to 1. So let's see. x1 squared plus 2x1 plus 2 equals x2 squared plus 2x2 plus 2. What can I cancel on the left and the right? 2. So now I have x1 squared plus 2x1 equals x2 squared plus 2x2. So far this is okay? Let's simplify this a bit. I could take x1 out here, couldn't I? So that's x1 plus 2, and this equals x2 plus 2. Now you're just looking for any solution. You just care if it's solvable, and solvable means it has at least one solution. And yeah, what could we use here? We could say let x1 equal 0 and x2 equals
0.
No, because we said they have to be different.
Okay.
1.
No.
Minus 2.
Minus 2.
Yes.
If I make x1 equal to 0, what will this be?
0.
0. If I make x2 equal to minus 2, what will this be?
0.
Are those values different?
No.
Yeah, these values are different.
Yeah,
But does it solve the equation?
Yes.
It does solve the equation. So it is solvable. So let's go back to the beginning. Let's calculate f of 0. What's f of 0? 2. And let's calculate f of minus 2. Minus 2 squared?
4.
Minus 4? 0. Plus 2?
2.
Many to 1. Okay, so will we get this method now? Write it down. and chill. You wrote this down? So, if we just look at the first one, I just did something from the second one, the method. But the first one, let's just do one together just to make sure you got it. So, can we all look up, please? Let me just zoom in on the very first question just to make sure you've got it. Right, this function h takes a and b and it gives you something from x, y, z. So h of a gives me z, h of a gives me x, h of b gives me z, and h of b gives me x. And we need to decide what type it is. Well, straight away I can see that it has a many in it for sure, because a goes to z and x. Can you see that? A goes to x and z. So it's definitely blank to many. But the question is it one to many or many to many?
Many.
Let's see. B goes to z, but also A goes to z. So we are looking at many to many again. Yeah. And let's do one more. Let's look at the next one. A goes to x. A goes to z. Okay, so this again is a something to many. C goes to y. So what do we think? One to many. Yes, because A gives you x and z and C gives you y. But if the x's are different, then the y's are different. So if you put in an A, you get a different answer than if you put in a C. So that makes it the one to many. If you have trouble with this, you can always draw it. So for example here, A, what else is there? And C. So you have A, B, C.
No, it only has A and C.
Oh, it only has A and C. Okay. And it goes to X, Y, Z. So A goes to X and Z. And then C goes to Y. So can you see how one value here gives you many answers? So it's definitely something to many. But different values here give me different answers. This one gives me XZ and this one here gives me Y. So then it's one to many here. Is it onto? Also, it is or isn't onto? It is onto, because the codomain, which is XYZ, is the same as the range, which is XYZ. Everybody has somebody, which is nice.
Except to me.
Yeah, sorry, we'll make it set here, and we'll have Faisal here. No, we need to put it in the other side, is it? Yeah, A, B, C. It doesn't quite map. Question, yes?
The first one.
Oh, great. Hang on, sorry. L. There now. Right, what's your question? Yes, what?
When are we finishing? That's my question.
I'm going to let you try these for a few minutes and then we finish. You're done listening to me, but I still want you to work. Question? No? No.
So,
Yes?
the first one,
Yeah.
A to X and Z is one to many.
Yeah.
But the C to Y is one to one. So why not part of that?
No, because you have to look at it all. So, like, for example, you're right, A is one to many, and C is one to one. So if you put them together, this is a one, and this is a many. So it's one to many. Okay. Good question. Right.